So welcome again. Today we are going to look at the blood supply of the brain. We will look at the arterial circle of Willis, or what the French call it, polygon de Willis. We will also look at the course of the anterior and the middle cerebral arteries. These are the branches of the internal carotid artery. So we can look at we can start by looking at the arterial circle of Willis. So this is the arterial circle of Willis, also known as circulus arteriosus or the polygon de Willis. Here you can see the vertebral. These are the vertebral arteries. The vertebral arteries. Yes, those are the vertebral arteries. Here they give off the two branches from the anterior side, fused to form the anterior spinal artery. The anterior spinal artery, remember, it runs in the anterior fissure of the spinal cord. Let me, for those who have forgotten, let me show you the origin of the vertebral artery. Remember, the vertebral artery originates from the subclavian artery. So this is the arch of the aorta over here. I hope you can see it. This is the arch of the aorta. Here we have the brachiocephalic trunk. The brachiocephalic trunk gives off the right subclavian artery and the right common carotid artery. Then also from the arch of the aorta, we have the left common carotid artery and the left subclavian artery. The subclavian artery is divided into three parts by scalenus anterior. The first part has 3 branches. Second, 1 branch. Third part, 1 branch. Branches from the first part include the internal mammary artery or the internal thoracic artery, this one. I hope you have seen it. Then we have a vertebral artery, this one here, vertebral artery. This is the vertebral artery. Then also from the first part, we have the thyrocervical trunk, which gives off the thyrocervical truncatus, which gives off the suprascapular artery, transverse cervical artery, also known as the superficial cervical artery, and terminates by giving off the inferior thyroid artery. Now, from the inferior thyroid artery, we have the ascending cervical artery. Also remember, from the inferior thyroid artery, we have our inferior laryngeal artery. So I hope you can see the vertebral artery. It usually ascends via the foramen transversarium from C6 to the atlas. Then here we have the horizontal segment, which is found in the suboccipital triangle. I will do the suboccipital triangle very soon, and I will discuss its boundaries. Then it pierces the posterior atlanto-occipital membrane. Then here it is where the 2 branches that fuse to form the anterior spinal artery are given off. Then the 2 vertebral artery fuse to form the basilar artery. This is the basilar artery. Then the basilar artery terminates by giving off the posterior cerebral artery, and that is how the vertebral. This is known as the vertebro-basilar system. So let's go back to our initial page. So you can see basilar artery terminates by giving off the posterior cerebral. Posterior cerebral artery communicates with the middle cerebral artery, a branch from the it is in fact a direct continuation. It's like a direct continuation of the internal carotid artery. Then also the internal carotid artery gives off the anterior cerebral artery. Anterior cerebral artery. The two anterior cerebral artery communicate via the anterior communicating artery. The posterior cerebral artery communicates the middle cerebral artery via the posterior communicating artery. So note that the arterial sac of Willis is found in the interpuduncular fossa or interpuduncular subarachnoid cistern. I hope I will do the interpuduncular subarachnoid cistern. I will mention its contents, boundaries in another video. So this is a diagrammatic representation. Let's look at the cadaveric representation. Here you can see the two vertebral arteries fused to form the basilar artery. Basilar artery terminates by giving off this one, the posterior cerebral artery, which communicates with the middle cerebral artery via the posterior communicating artery. This whole system is the arterial circle of Willis. This is an anastomosis between the internal branches from the internal carotid artery and from the vertebral basilar system. So I can show you where it is usually located. This is where it is usually located, in the interpuduncular cistern. Yeah. These are your vertebral arteries. This and this, they fuse to form the basilar. Basilar artery lies in the basilar groove of the pons, then terminates by giving off the posterior. This is the posterior cerebral artery over there. The internal carotid terminates by giving off middle cerebral. This is the middle cerebral artery. We will look at the cause later. Then also by the anterior cerebral, those ones, that is one. So more diagrams to show you. This is the vertebral arteries, this and this, they fuse to form basilar. Now, from the basilar artery, we have some branches. We have the Pontine Arteries, which supply the pons. We also have the anterior inferior cerebral artery. As the name suggests, it supplies the antero-inferior aspect of the cerebellum. We have the superior cerebral artery, which supplies the superior aspect of the cerebellum. So I've said the terminal branches of the basilar artery are the posterior cerebral arteries. Yeah. More images for you to see. These are the vertebral, that and that. They fuse to form our basilar. You can see the superior. This is the superior cerebral artery. Then from here you can see the Pontine arteries, these small ones. Here's the anterior inferior cerebral artery. Note that the anterior inferior cerebral artery, it can give off the labyrinthine artery. The labyrinthine artery can either originate directly from the basilar or from the anterior inferior cerebral artery. Remember, the labyrinthine artery exits the skull, then the cranial cavity via the internal auditory meters. It goes to the ear to supply the ear. So this is more of a diagrammatic representation. These are the vertebral artery, basilar. These are your anterior cerebral. You can see they are arching around the corpus callosum. We will look at the cause very shortly. You can see the middle cerebral. They usually lie on the insular cortex there, along inside the lateral fissure of cerevium. So we can now look at the cause, or one more diagram to show you. This is the superior aspect. This is an superior aspect of the cerebellum. Here you can see the midbrain, the mesencephalon. Here you can see the habenula commissure, pineal gland. Pineal gland, I will look at the endocrine glands in another video. You can see here the superior cerebral artery, that one. This is a lateral branch from the superior cerebral artery. These are the posterior cerebral artery, that one. So let's look at the cause of the anterior cerebral artery. Now, I've said the anterior cerebral artery is a terminal branch from the internal carotid artery, but it is the smaller terminal branch. The larger one is middle cerebral. So it runs forwards medially above the optic nerve to the commencement of the median longitudinal cerebral fissure. So you can see here, it runs forwards and medially to the commencement of the, this is the middle cerebral fissure, or the interhemispherical fissure, that one, the longitudinal fissure. After reaching there, it comes very close to its fellow. Remember, there is a right and a left. So they get joined. They are joined by a short transverse anterior communicating artery. So you can see here, this one, a communicating artery, the anterior communicating artery there, where they come to lie close. Then the anterior cerebral artery then curves around the genu of corpus callosum. The branches given off just distal to anterior communicating artery supply the medial part of the orbital surface of the frontal lobe. The artery continues along the upper surface of corpus callosum as the pericardoso artery. So pericardoso artery is the continuation of the anterior cerebral artery. It gives off a large branch, the callosomarginal artery, which runs in the cingulate sulcus near the splenium of corpus, which runs in the cingulate sulcus. Then how does it terminate the anterior cerebral artery as the pericardoso artery? Near the splenium of corpus callosum, the artery ends by anastomosing with the branches of the posterior cerebral artery. So with this description, you have a very good essay of the cause of the anterior cerebral artery. So let's look at the middle cerebral artery, shorter one. The middle cerebral artery is the larger terminal branch of the internal carotid artery. It appears to be a direct continuation of the internal carotid artery and carries about 30% of the carotid blood flow. The middle cerebral artery first runs laterally in the stem of the lateral sulcus. Remember, the lateral sulcus is also known as the cerevian sulcus, and then turns backwards and upwards in the posterior ramus of the lateral sulcus, where it breaks into branches which are named according to the lobes to which they supply, the frontal, parietal, and temporal, which emerge from the lateral sulcus and run towards the areas of their supply. Some of these branches are usually named. We have such as the pre-rhorandic artery, rhorandic artery. We also have an orbitofrontal artery. So that is the cause of the middle cerebral artery. I hope you have understood. Yes. So I hope this is image. So let me show you the middle cerebral. This is the middle cerebral artery. You can see it is running in the lateral sulcus, the cerevian fissure, that is. Yes. One final look at this. So this you should know every detail about the arterial circle of Willis, polygon de Willis, circulus arteriosus. Should know how these arteries anastomose. Yes. With that, I would like to say thank you and thank you for your attention. Please subscribe, guys, for more amazing content. These slides were compiled by Yure Daktari and kids. Thank you. If you want the slides, I will put details in my description. You can look on how to get this. Thank you.